Okay, this is the third video. Here we go. Okay, the first two video, we hopefully got a little bit a better understanding of reciprocal identities. Okay. Now, the next ones we're going to learn are these here, the ratio identities. Now, remember when you learned sine, cosine, tangent? You kind of learned sine, cosine, tangent, but when you learn those three, you kind of also learn the other three, right? We did that over here. We're going to do it again here in this triangle. This same triangle for this angle here. Sometimes you use this little angle. This is the symbol for an angle. It's called theta. Or sometimes you use the letters, A, B, C. But we know that, let's label this is the opposite side. This is the hypotenuse side. This is the adjacent side. We know that, again, sine of theta is so. We know it's over h, so it's 5 over 13. Cosine of theta of the angle is adjacent ca, 12 over 13. And tangent is opposite over adjacent, 5 over 12, TOA, right? But if you look at these ratio identities, we're really looking at just tangent and cotangent, right? Remember when you learn these three, I really know these other three, you just reciprocal, reciprocal, reciprocal. Well, I'm going to tell you the same thing here. You really don't need to learn these two. You just really need to learn this one, right? If tangent, remember tangent, whatever tangent is, I'm going to show you here. Remember, if you know tangent, you really know cotangent is just the reciprocal. If this is 5 over 12, I don't need to learn this one. If I can get this one, I know this one. If this is 5 over 12, this is 12 over 5. Okay, remember that. We know that. We know that tangent and cotangent go together. Okay. So, this new formula, this is new. And we're not going to talk about this, these other, what is it, cosecant and secant. We're not gonna need those. As a matter of fact, you're going to realize now that from now on, you're really only going to work with sine and cosine. You're not going to need cosecant. You're not going to need, what is it, secant. And you're really not going to need tangent. Not like this. Not the way you know TOA. Okay? So, what is this new identity? This new identity tells us that tangent is sine over cosine. This is the new one. This is the new identity. Well, let's see if that's true. I already know the answer for tangent, but remember, we're really not going to use tangent anymore. You're really going to eliminate these other four. You're really only going to work with sine and cosine. So if you understand this, you're not going to have to work with all these 6. You're really going to have to just work with sine and cosine. And actually tangent, but you're going to see tangent is really what? Sine and cosine, see? You're not going to see tangent as opposite over adjacent. It's still true, but I'm going to prove to you why you can use it as sine over cosine. Now, this is going to look like more work, but later I'm just going to show you how it's easier. Again, just accept this new one. For tangent, do not use opposite over adjacent anymore. Understand that tangent is sine over cosine. Okay, so let's say I don't know the answer. I know tangent is 5, but let's pretend we don't know it. According to this, it says tangent is sine over cosine. Well, that would mean that tangent is sine. Sine is what? 5 over 13 divided by what? Cosine, which is 12 over 13. Hey, we've been doing this. Remember I told you, you want to see this? You want a fraction divided by a fraction? All right, well, let's solve this. Let's simplify. Let's simplify this. That would be what? Let's evaluate this. That would be 5 over 13 divided by 12 over 13, which is really going to be 5 over 13 times what? 13 over 12. And what do you guys notice here? I'm telling you, once you get to this part, when it's in multiplication mode, always look for something to cancel. What cancels? You guys can see it. 13s, right? This 13 cancels with this 13. Or remember, I told you we already knew the answer was 5 over 12. The answer is 5 over 12. We knew it from over here. Okay, I'm just proving to you that it works, that tangent is sine over cosine. Tangent is now going to be sine over cosine. Don't see it as O over A, because really, remember, you're only going to work with sine over cosine, right? So I proved it to you. You don't have to prove it. Just know it and memorize it. The tangent is now, another way to look at tangent is sine over cosine. It's 5 over 12. And if tangent is 5 over 12, right? If tangent is 5 over 12, which is sine over cosine, then if you know this one, remember how tangent and cotangent go together? Well, if it's true that tangent is sine over cosine, then you also know a new formula for cotangent, right? And remember, if I know tangent is 5 over 12, what do I have to do to get cotangent? Just the reciprocal, right? So if now I'm accepting this, tangent is sine over cosine, then it's also going to be true that cotangent is not going to be sine over cosine, right? They're not equal to each other. Cotangent would be what? The reciprocal. Cosine over sine. Yeah? So if you know this one, you know this one, right? This is now our new formula for sine. Okay, so remember that. Okay, so we'll do some problems. You'll work with this. But essentially what you're going to realize on these identities, you're not going to use all 6. You're not going to use sine, cosine, tangent, secant, cosecant, cotangent. That's crazy. What I'm going to show you is how to make it really simple. Instead of working with all 6, you're only going to work with 2, sine and cosine. Sine and cosine. And actually, yes, you'll use tangent. You'll use tangent, but this tangent. And this tangent is what? Sine and cosine. See, this is sine, this is cosine, and tangent now is going to be sine over cosine. All right? Okay, so we'll see some examples and you'll get to practice and you'll get better with it. Okay, so there it is. All right, so this is the new one. This is the ratio identity. I know that tangent and cotangent are reciprocal of each other. If tangent is this over this, then that means that cotangent would have to be what? Right? Sine was on the top, cosine's in the bottom. Then that means for this one, what? Cosine's in the top, sine's in the bottom, right? But you don't have to memorize both. Just remember this. Tangent is sine over cosine. Then you'll know that for cotangent, you just flip it over. It's cosine over sine. All right, we'll talk about it in the notes. There you go.